Testing. Okay. Welcome. Let's see if we can have some people show up in the chat. Just making sure that this compiles. Let's see if someone else shows up. It's in the middle of the day. Oh, I should probably turn off the SID play. Okay, there we go. Okay, thank you, SID play. Sometimes it doesn't feel like it's that accurate. SID play. I mean, anyway, here we are. This whole thing started with spoiler. This started with someone posting or not, didn't start with that. This started with someone. This started with, like, since the beginning when we used Const enums, started to have them, right? If someone recalls, the problem that we're trying to solve was C interoperability, right? And we went through a bunch of ways to do this, right? So initially we had something like this. We could have like a value 1. We can have an associated val here, right? And now it doesn't look good because of how it is. But then you would do something like try to do, extern my function. Foo, and try to call it like my func, ABC. So you really wanted to do this, but the problem was that if I do this, then it will pass a 0 because this is the ordinal of ABC is 0. So you would have to be like explicit about it. And we added features, like if you did try to do things like if you had a change, the syntax change to this, so it would be like a little nicer. And if you would use it in this way, and it would have inline, and then if this would say int like this, then the inline, this actually exists still in 0.7 because we would try to fix this during 0.7. Then if you did this, then it would use this inline here to do the conversion, like you implicitly set that val and do it here. But then you lose, type safety. So then you would have to, like, if you really wanted to be good, then you would define a foo val, a distinct one, right? Like this, and have that one here. And then the value is a foo val. And now this, like, is safe. But this song and dance is not very nice, right? So eventually I kind of did bite the bullet and decided to introduce oh, hang on, just gonna check for 1 second here. Yeah, maybe people are like so I changed this to, you could do like const int, right? And now it just became like this enum, right? So now everything works like this. And then people started to like complain. Oh, why do we have two? Because I wanted to make this cleaner and clearer. So I just, we were talking about this, const enum, like this, right? And people were starting to complain, like, why do you have the old enums? I don't like the old enums. The old enums should die. Not like that, but yeah, pretty much like that. And basically, they didn't understand what features you got from enums. Okay, and then they wanted to destroy those features. So what do you get from having that? So if I have a enum like this, right, yeah, then at runtime, if I want to just update the settings here. So use the center library. So okay, so if I just do like this, I have a runtime value, which is the and I print that one. Now what do we get here? So printing this one gives us def, right? So it gives us the name. And actually at runtime, I can also do this. So I can get like enum from name, right? I think that's it. And then I take the foo, and then I say like ABC. I don't recall if this is, and then I could print that one. See which one it was. Enum from name. Enum from name. Is it that the name? I will find out. So okay. No. Enum by name. Be by name. Okay. Consistency. Okay, so now we get an optional here because we can have like We might not find it, but we'll panic if we don't find it. Right? And we get like ABC here, right? So we get it back and forth. But we can also convert it to an ordinal, right? This f we got, we can just grab the ordinal or we just cast it. And if we do that, of course, we get the underlying value, and then we can just cast it back. So we have int value. This is not rocket science, so we can get like h as, you know, full I. And we print that one as well. So remember, these are not compile time resolved. These are runtime values. So in this case, we get, you know, the thing back. So df, right, the one that costs 2. Now, the problem, right, is that if we instead do a const int right here, we get quite different thing. So one of the things, okay, so one of the things that you kind of always have to do when you're dealing with enums in C is that you create a switch. Right? You have a switch because you wanted to debug, you know what the enum was. Grab the name from the value. So by hand, or let's just go to the constant. So if you do const int right now, then you discover that, oh, you can't do the enum by name. Okay, right, we that one. We can, let's see what else we can do. Okay, there's wording, but let's ignore that for now. So we get 1 1 1 1, right? Because it's just a number. And this is just like C. So if we want to actually know the name, then we have to do like we can make actually a function here from to string, right? And then we take this full, and then we do a switch, and then switch on self, and then we have like case ABC, return ABC, okay, and then case df, return df, right? And default is like, I don't know, default, right? So because and then we can do something like, actually we can set this one to printable, to format. But let's ignore that. So now we can print like f to string, and everyone is, you know, happy because suddenly we can get like def. But as soon as I add something to this, like this, then I have to add it. What happens if I like do other things? You can maintain this in a different way, right? You can maintain this as it's like this. So you have like foo a plus 1. Okay, so that's the length of it. And remember, if you probably have to add inline here. Let's add that one. So this equals then your foo strings. And then you have like ABC is ABC, df is df, right? Right, and we can use that instead of a switch because it's kind of faster, right? But anyway, like let's say we want to have like, okay, for every one of these, what is the get a value from there, right? So step length, self, and then we have to create a switch. Then we have, okay, ABC, return if case, ABC, return 3, case DEF, return 100, case GI, return. And then finally we can do default, reachable, like that. Okay, so now we can get like this associated value for the step length. Like we have the f like the you print then, and like f step length. So this can absolutely be done like this, right? It's just that if I have instead normal ones, I don't need this. I can just say, okay, we want to store a step in step length, right? And then we want to say, like right now the syntax is like this. We will change it, but that's right? And we don't need any of these helpers, and we can just, as before, like this was the thing we did. So we are now basically you get this. Sorry. Okay. Did I do something wrong here? Only macros function invoked. Oh, okay. So it's not a function anymore, right? So it's actually it is just indexing. So the step length is it's sufficiently stored as well. So you get the same thing, and there's no switch. It's basically this array that I was talking about. Like basically we have, step something like in step lengths, and then we have, this is what's created for us. So that instead of, why do you see syntax? Okay. So instead, so basically it becomes like when you do f step length, what you do is actually a step length ordinal. And the ordinal is actually not a lookup, that's just the underlying value. So these are the same. These two are the same. But as you saw, for the other one, we need to actually explicitly, you have to, you can do like this, right? But then you do not associate with this. If you have maintained this, you know that this just makes things shitty. Because you don't, like, if you ever change the enum, then maybe like you rewarded them or something, then you have to reorder here as well. If you don't do this thing, that works. But then you can get, like, if you remove something, you then get empty places in here. It's just not great. So the usual way to solve this in C is to use X macros. You can look up the X macros. So like X macros, right? And that one lets us define things. Can I grab an example from the internet? X macros enums. Let's see if I have this something I can copy paste. I don't use that for the compiler actually. So like, let's see here. So did someone have some nice example here in the, okay. So basically you would do something like, well, you end up with code looking like this. Basically something like this at the top level, right? And that one is defining, like going back and defining things. So this if I did something like ABC, DF, and then having those numbers, and so on, then that would be equivalent. So those are the problem to solve with the C enums are, one is like printing the names, right? Going back and forth, by the way. And then two, all the like X macros, avoiding them. Like, since you can't do an X macro in C3, you kind of need some way to kind of associate, like if you want to declare things together, there is no real way of doing that. You don't have those pre-processor things. You can't construct an enum at compile time with macros in C3. So so this is what I tried to fix, right? These use cases that are hard. They're very, very hard to maintain. I didn't try to fix the case with C enums because I thought that, yeah, well, if we go back and like look at what we had, then we could, if you just want those mappings that are random, right? So you want these const enums, const int, for example, right? This would now, like if you do this, you could get these numbers, right? So you get 3, 100, you know, this should work. Okay, 100 for everyone because all, yeah, that's the number. So I didn't try to solve this because actually this one is the same as doing like creating a type def and then creating these constants. Const foo abc equals 3, const foo def equals 100. Like this is just creating, this is just about creating constants. These are the same. The only thing here is like if I delete this, right? Okay, and now I can still compile it. It's the same thing. And that's what C enums are. They are a list of constants that where you get like a convenience to increase the number. So that's why Go doesn't have enums. That's why like PHP, I don't know if they have enums now, but they didn't have for a long time. So it's not necessary. You can't iterate. I mean, in C, you can't like, oh, let's iterate over all these enums. You can't even do that in C. So those are just glorified constants, and this is actually powerful. If you have something that has an API to other systems, then you might want to deprecate some enum values. So there are things like you can do in C. You can do like, okay, you have if you have this, right, then I could create another who my best ABC and then call it 3, and then we can say like this is deprecated and use this one instead, and then we can support both, right? And this one is added on top, so we can say like just add this if you know, version is greater than 3, right? So it's not even available. So this kind of thing where, but in the C, with C syntax, right? So you can add these and deprecate them separately. That's what you're, because it's not even in C, it's not even namespaced, right? It's not like the class enums in C++, which is trying to do like have some namespacing and stuff. So suggestions that this should replace enums is like, throw away the need for X macros. No one uses X macros, right? And no one needs ever to print the name of an enum. That admittedly pisses me off a little, because this has been like in a larger projects. This is like such a big hassle. Like if you use enums to for example, you have state transitions, right? So states transition to each other, and then you want to track the state and you want to print what is the state, the current state. Maybe you even have like, yeah, this state can only transition to these states, like a check. So you can add a check, like if it's, if you're asking it to go to another state, you can check that the state before that was not the other states. So I can actually show you an example of that. So we have like state, right? And we have also a list here of states. Oh, I hope this worked. I didn't think about, like, maybe it's just self-referential should work, right? So we have a list of states that are allowed, and then we have like running, idle, right? And then we have like running, and then we have the stop. Okay, but like we are only allowed to have, you can go to idle, you can never go to idle, for example. Maybe there is no previous state. Running, we should have gone from idle, right? And stopped can go from, idle or running. So now we have like this void set state. We have some state which starts as state is idle. And then we can set the state, new state. And then we have, oh god, if new state allowed. Oh, well, I have to look into those. Maybe we have some previous. If not, if previous is not. Yeah, this. Okay, so if state previous is not state, then we just abort. Oh no. Okay, otherwise we set the state is the new state, and we print. Enter state from blah blah blah. So we have the new state. Okay. So in this case, we might set like set state running, and then set state. What was it? Stopped. And then we set state idle. Let's just I just randomly just take types down there now. Okay. Okay. So we get enter state running from idle, enter state stopped from running, and then we have one. So this is kind of when we do debugging and things like that for these kind of things. This is very useful. If you do a lot of this, then the values, like, it's super high. If you have like, if you want to maintain this in with like this Const enum, like C enums, then this is annoying as hell. Like you need to keep those not names, you need to keep this like list of what they are available, and they had to be like separate, and it's so easy to get the wrong thing. Here it's very obvious, right? So idle can translate it to idle, running to running, and we see that like straight off here, right? I wonder if this works now, right? I did change the syntax to support this. Does that work? No, it didn't work. Okay. Let me. I'll fix that sometime later. So I am killing off the Const enums in the sense that they're called enums. So they are not going to be any Const enums. They're not going to be like they're not going to be any enums or something like that. But we are going to keep the functionality. And we are just going to keep this functionality just this type def plus constants. So we are getting const def. Okay, so the const def rule here is like before. It's basically you could think of this as saying enum, but it's not a enum, so it's not that. So you get this, right? It's just a collection of constants. So ABC is just a constant, right? So because it's a constant, you can't, if you print, foo ABC, then that's a constant. It's just a type. It just happens to be a constant, right? And you can cast anything to it, right? So you can take something like this and do it. It doesn't matter. There are no, like, unlike enums, this is well defined and fine, right? So we can still do this, right? Well, let's say we have a function on this one. So we have a string, foo molt, and then we take the self, and then we're going to take the self and multiply by itself, and then we just return that in here. Okay. So then we can do like this and do molt on B. We can do it on the ABC. So both of those works, and now of course it's not going to be very exciting. So, but it's doing the same. Like it doesn't care that it's not part of this original const def. I'm actually thinking of maybe have like actually you be able to do like foo, and then you say extend, and then you like have more of them here so that you can iterate over them. But already you could like, and you can use the namespacing. So maybe that will happen. But these are clearly constants. So if you go and look for something and you feel like this should not be an enum, right? This is not an enumeration. This is just a collection of constants that I want to model in a particular way. Then you use const def, right? And you do get, this functionality if you want it, but only for integers. And now it's more natural that you can do like a string, which is like something here and something else, right? So, I don't know why why did the highlighting break? Okay, didn't like that. Okay, but if we have this, right, now we can't do this. What can we do? If we print this here, right? Oops, we didn't have a B anymore. But printing this, of course, gives the underlying string. Right? So this is a new one. We are getting const def we are not getting const enums or enums. It's an ugly name, but at least it matches, the type def, because it's like a combination of doing a type def and declaring constants. So what you do get is this, like on top of type def is that you get this. So you can have this in parents. So that's the only convenience on top. I wonder why it's not working. I think int should work. Like int works, but as soon as you do something else, it's like, no, you can't have that. So that's interesting. Double worked. Okay. Probably something wrong in that. The grammar there. Okay. So that was it. Let me see if there are any questions. Is this VS Code or why do people actually, spam things? I don't know. Okay, is this VS Code or VS Code? It's just IntelliJ. It's actually CLion, right? So, any questions? No? I'm sorry that I felt that this happened. I guess I would have liked to, I tried my best to unify things with enums, but it's just they are so different that that doesn't make sense. It just gets confusing, right? Like as soon as people started to find, if that would be like, oh, if we had an enum, right, and someone said, oh, okay, 0, then we got the const enum, right? No, that's just, I know it's familiar, but you get to do this. Right. Okay, that's all. I'm going to push this live on master. I'm going to write the release notes, which I haven't done yet. But that's the new thing. Okay. Thank you for watching. Have a great day.